Okay guys, so I showed you this example using a pretty straightforward method of linear combination with multiplication, or I call it elimination, because we're eliminating a variable. But there's something I noticed about these two equations, that I could actually treat this a little bit differently and make my numbers smaller instead of making them bigger. Well, I happen to notice that this first equation, all the coefficients or all the numbers are divisible by 3. Excuse me. And in the second one, they're all divisible by 4. So instead of multiplying the top by 4 and the bottom one by 3, I'm actually going to multiply the top one by 1/3. And then I'm going to multiply the bottom one by 1/4. And this just, I think, happens to be lucky. So when I distribute this 1/3, I end up with negative x plus 3y equals 12. And then when I multiply through by 1/4, I get x plus 3y equals 6. So I did some multiplication, but it was really kind of division. But that's what division is multiplying by a fraction. So now when I combine these, because I nicely got rid of my coefficients for x, my negative x and x eliminate each other. So I end up with 6y equals 18. Divide both sides by 6, and I get y equals 3, which is what I got before. So it's just kind of a neat little thing, and maybe something you might just want to keep your eyes out for. It probably won't happen very often. So I think this is our last example here. And I know when I first saw it, I went, oh gosh, fractions. Oh, my kids are going to hate this. But this is actually not as bad, because notice that all those denominators are the same. That's kind of nice, because I can multiply this. Here, where's my cursor? There we go. Since all the denominators are the same, I can pretty much ignore them by multiplying by that denominator. So then I get 7x minus y equals 9. And then the bottom one, well, it's not in the form that we would want it to be in. But it is solved for y. So instead of using elimination, I'm going to use substitution. Even though this is a lesson about elimination, it's more about the multiplying part. So I'm going to take that y equals and put it in for y in my new equation. So I'm going to have 7x minus 3x minus 5 equals 9. And the reason why I have to put that in parentheses is because that's what y is, and I have to treat that y as if it's one thing. So now I just have to distribute this negative sign, or think of it as a -1, and I get 7x minus 3x plus 5 equals 9. Combine some like terms here and subtract 5. So I get 4x equals 4, and I get x equals 1. Well, that's really cool. And now I need to find y. Well, I'm not going to bother with those fractions. And besides, the second one's already solved for y, so it's just what I call a plug and chug. So, cursor now. There we go. Okay. So I know that x is 1. So I say y equals 3 times 1 minus 5. So y equals 3 minus 5, or y equals negative 2. So I get an answer of, or a solution of 1 comma negative 2. Now, I really should check these. I really should, especially since we have those fractions involved. So let me just erase this so I can see the things again. I know this is so exciting. And this is the checking. Now I'm just checking everything. So x is 1. So 7 halves times 1 minus 1 half times negative 2. That should equal 9 halves. Well, 7 halves times 1, well, anything times 1 is whatever that was. So that's just becomes 7 halves. Negative 1 half times negative 2. That becomes a 1. But since we have denominators, I'm going to call it a 2 over 2. And 9 halves. So does 7 halves plus 2 halves equals 9 halves? Well, if you remember how add our fractions, and our denominators are the same, we just add the numerators. So we get 9 halves equals 9 halves. So it checks the first equation. And we suspect that it's going to work in the second equation since that's how we found it. But let's say, does negative 2 equal 3 times 1 minus 5? Negative 2 equals 3 minus 5. These are all questions, of course. Negative 2 equals negative 2, and so it checks in the bottom equation. I know that started to sound really boring, so I'm sorry about that. Gosh, I'm not usually like that. So that was, I think, our last example. Here is, well, this was recorded on Friday, so, and actually some changes have been made since then. The quiz in 1.04, it was supposed to close Sunday night. I actually changed it to close Wednesday night. The other ones I think are remaining the same. I don't think any changes have been made to those. So, of course, what should you be working on? The lesson we just did, of course. And anything else that you're overdue on. 2, 1. And, whoops. Let me look up the URL for the exit ticket. I really like this quote, and I think it's kind of neat. So the exit ticket actually does ask for your feedback on it. So I'm going to write out this URL as soon as I get it. There we go. Maybe I'll just paste it here. There we go. So that is our exit ticket from this particular lesson. So I hope this was helpful. I had a lot of fun with it, and just if you have any questions, let me know. That's what I'm here for. Bye.